Okay, we're going to take a look at arithmetic and geometric sequences and some series as well in this tutorial. So the first thing that I want to do is just create general equations for these sequences. So firstly we need to determine what is happening to get from one value to the next, and you can pretty obviously see that this is multiplying by 2. So our R value here, which is a multiple, is 2, and our A value is 1. So we're basically just going to plug it into the term formula for a geometric sequence. Okay, so what we're going to have is an A value of 1 and an R value of 2 and an n minus 1 as the exponent. This is our general equation. Okay, this next one here, we can see we are adding 2 to get to next values in this sequence, making it arithmetic. So my A value again is 1 here, and now we have a D value, which is 2. So we're just going to plug in A and D into the arithmetic sequence formula. Sorry, that should be a D there. I'm getting ahead of myself. Okay, so here's my A, which is 1, n minus 1 will stay as n minus 1, and D can be entered in as 2. There's my general equation. Okay, we can use any of these equations basically to determine any term we want in this sequence. I could find term 100 in both of these sequences now that I have these two formulas. Okay, here's our next example. This is asking us to determine the sum of this series, but first we kind of need to figure out how many terms are actually in this series. What is this term number? Because if I'm trying to find the sum of a certain number of terms, I need to know how many terms I'm finding the sum of. Otherwise, I cannot use the formula. Okay, so there's a couple things we know already. We know that the A value is negative 31. And we know that this is arithmetic because we're adding 4 to get to each number. We're subtracting 4 actually. So our D value is negative 4. Okay, so I also know the value of the last term, which is negative 403, and we want to know what is the term number for that. Okay, so I'm going to use my sequence formula. Okay, and I'm going to plug in what I know. I know the value of the last term, and I know the value of the first term. I don't know what the term number is for the last term, and I know the D value. Okay. What I really want to know is just how many terms are in this sequence. So I'm going to bring the 31 over. Okay, we'll get negative 403 plus 31, and then n minus 1 times negative 4. Don't worry about distributing that negative 4 in there. We're going to divide it out anyways, so we don't want to do that actually. Okay, we're going to end up with negative 372 on this side. Okay, and I just want to divide out that 4 there, or the negative 4. Okay, this is going to help me get n by itself. Okay, so that divided by negative 4 is going to give us 93, and then I'll just put that 1 over, and that means that we have 93 plus 1. So we have 94 terms in this series. Now that we know that, it's pretty straightforward from here on out. We're just going to plug right into the sum formula for an arithmetic series. So, and because I know the first and last term of my sequence, I can use this first and last term formula here. So we're going to find the sum of 94 terms, where the first term is negative 31. And the last term is negative 403. Okay, so 94 divided by 2 gets us 47, and negative 31 plus negative 403 gives us negative 434. And we're just going to multiply those two things together, and we have the sum of our 94 terms. Okay, negative 2,398. And there's our solution. Alright, the last question that I want to show you is a question where we have to use elimination to solve. So we're given that T12 in an arithmetic sequence is equal to 35. and that the sum of the first 20 terms of that sequence is 610. And we want to find the first 3 terms of the sequence. So in order to find the first 3 terms, I need to know what's the first term, okay, the a value, and I need to know the d value as well. So I'm going to set up 2 equations with the arithmetic sequence formula for the first one because it's a term information that we're given. And then I'm going to set one up as well with the arithmetic sum formula because that second piece of information deals with the sum. Okay, so what do we know? We know 12, term 12. We don't know a, but if I'm going to put in term 12, I need to put in 12 for that n as well. And I know that term 12 is 35. Okay, and we'll just simplify out a little bit here. Okay, what else I know is that we have S20. Okay, so that's going to mean I'm putting 20 in for all n's here. Okay, 20 minus 1 times d. And I know that S20 is 610. So again, I'm just simplifying a little bit here. And what I'm actually going to do is, seeing as we have a value outside here, I don't want to do that if I'm going to end up using elimination, so I'm actually just going to divide it out. So 610 divided by 10. Do that quickly here. 61. Okay, so here's what we have. We have 2 equations with 2 of the same unknowns. And what we're going to do is we're going to kind of set them up so that we can use elimination here. So in order to use elimination, I need to have either the a's being the same or the d's being the same. Right now I don't have either of those 2 things, but if I multiply this entire equation by 2, I should have 2a. And we're going to subtract here so that we can eliminate the a's. So 61 minus 70 will give us negative 9. And 19 minus 22 will give us negative 3d. Okay, this tells me that d is equal to 3. Okay, so now that we have d is equal to 3, all I need to do is find the a value by plugging it back in, and then I can find the first 3 terms. So I'm just going to do that on the next slide so that we have enough space here. So 35 equals a plus 11 times 3. Okay, so we get 35 minus 33 equals the a value, so our a is 2. And now I have 2 plus 3, which is 5, plus another 3 gives us 8. And if we wanted to continue, we could, but it just asks us for the first 3 terms, so there they are.